Okay, this video is going to walk us through creation of a Snap instance. After logging in, we see the following screen. We have a number of Snap instances that we can edit and a few user actions over here on the left side, such as help screen. For first-time users should probably read through the help screen, which describes how to do a Snap specification. So we're going to create a snap model for a very simple task, which is one of the parts of tea making, where a person has to open the garbage bin lid and throw out the tea bag. I'm making this task very simple so that we can get it done in a reasonable amount of time. The first thing we need to do is specify a set of environment variables. So we will have two different environment variables. One is the state of the bin lid, so I'll call that bin lid, and this can be open, but it will not likely be closed when we start, so we'll say with very small probability will it be open. And now I will add a second value for that state, which is closed, which has a 99% chance. The second variable that we will add is whether or not the tea bag has been thrown into the bin, so we'll call that tea bag in bin, and that will be yes with 0 probability when the person starts, because they won't have thrown it in the bin, and no with a probability of 1. Okay, so now we've specified our environment variables. The next thing that we do is specify the behaviors of the person. There are always two behaviors present, other and nothing. We are going to add 2 more, which will be open the bin. We can specify a timeout for this variable. Let's say it's going to be 20 seconds. And we'll add another behavior, which is to throw the tea bag into the bin. And this will have a shorter timeout of 5 seconds. Once we've done that, we add the abilities that the person will need. So they will need a number of abilities. They'll have to be able to recognize the bin. This will be a recognition ability. And we have to specify a number of different probabilities. What is the probability that they will gain this ability if they don't have it and are not given a prompt? We'll make this fairly low. The probability that they'll lose this ability, we'll make this also fairly low. Probability that they will gain an ability if they're given a prompt for that ability, we'll make this fairly high. They are likely to, this is likely to work, and not very likely that they'll lose that ability if they're given a prompt. The initial probability for this ability, we don't know whether they have it or not when they start, and we'll give it a cost of 1, which we can play with later. Now we're going to add a second ability, which will be to see the affordance of throwing the tea bag into the bin. We'll call that affordance throw tea bag. And this will be an affordance prompt, and I will just leave these numbers the same as the other ability so that we can rapidly get this one in there. So now we have 2 abilities, and we can move on to look at our sensors. So the first thing we'll do is we will add a few sensor observation names. The first one will say that we have a door switch or a bin lid switch. Let's call it the lid switch. This can indicate that the lid is open, or it can indicate that the lid is closed. Now let's suppose we have another observation, which is a computer vision system that can recognize the person throwing the tea bag into the bin. So we'll call that throw gesture, and that can be yes if the throw gesture is recognized, or it can be no if the throw gesture is not recognized. Once we've defined our observations, we can go and connect them to the environment and behaviors which we've already specified by looking at the sensor model. So let's edit the sensor model first for the bin lid switch. So the lid switch will say closed when the bin lid is actually closed with probability 0.99. That's a very accurate switch to detect that the bin lid is actually closed. So it will say that but it will report open, so it will give a false positive only 1% of the time. On the other hand, if the bin lid is open, and the lid switch will say open, let's say 95% of the time, and it will say closed 5% of the time. So this defines a sensor and how it is connected to the sensor is the observation name, and defines how it is connected to a particular variable in our model, which is the bin lid. Now let's connect in our computer vision gesture sensor, which is our throw gesture, and we'll say that our throw gesture will be connected to the behaviors of the user. The throw gesture will be yes if the behavior is throw the tea bag with some probability. Let's say this computer vision system is reasonably good at detecting this throwing motion, has about a 75% recognition rate. But then it will report no 25% of the time. So it misses the gesture 25% of the time. Now that we've put in our sensor model, we can move on to looking at the world model. To do this, we need to specify these two tables, the effects of behaviors and the preconditions for effects of behaviors. So to do this, we first of all need to specify a number of different behavior effect IDs. So we'll start with number 1, and so we'll say that the behavior of throwing the tea bag is going to make the tea bag be in the bin. Now we'll add a second behavior effect, which will be based on opening the bin is the behavior, and this will cause the bin lid to be open. Now once we've specified what these behaviors are doing to the world, we need to specify the preconditions for each of the sets of behaviors we've defined here. So we go to the preconditions and we say, well, for the first behavior effect ID, which was throwing the tea bag into the bin, well, the tea bag must not be in the bin in order for that to have an effect. Now we'll add the second precondition. So for the second behavior effect, this is opening the lid. The precondition is that the bin lid must be closed for opening the bin lid to have any effect. Okay, now we've done the world model, we can move on to specifying the full IU table. Now, the way that we're going to do this is we're going to basically describe the task that we want to accomplish here. So we will add a new data row. We'll need about 2 rows for this. And we will edit this row by clicking here. So our goals are going to be to have the tea bag in the bin. So we'll add that as a new goal. The task states to begin with are going to be that the bin lid is initially going to be closed, and the tea bag will initially not be in the bin. The abilities that are necessary at this stage, the first thing that the client has to do is to open the bin lid. So they will need to be able to recognize the bin in order to do that. And the behavior that they will need to do is open the bin. Since there will only be one choice there, the probability of that happening will be 1. Now we're going to add a second data row, and we will edit that. Our goals will still be to get the tea bag into the bin. The task states will now be that the bin lid should be open, and that the tea bag should still be not in the bin. The ability at this stage is to see the affordance of throwing the tea bag into the bin, and the behavior that we would expect from a client is to throw the tea bag into the bin. Again, there's only one behavior, so the probability is 1. At this stage, we're done with the U table. So we need to do a few more things, checking the subsumption of states, which here it says that everything is okay, and to see if there's any disjunctive behaviors, and that has not found anything, so we are good to go. We need to do a few more things to finish this model. The first is to specify a number of different rewards, and we specify rewards for sets of states. So we'll have the first set of states, we'll only have one reward, which will be the reward of 15 for completing the task. And now we will need to go and define what that set of states is. So that first set of states will have the tea bag in the bin being yes. We can also specify that we want the bin lid to be closed, but I won't add that to this particular model. The last thing we need to do is specify when behaviors are impossible. So we will specify once again a couple of different situations. For example, it is not possible to open the door if the door is already open. Open the bin if the bin is already open. So opening the bin is not possible in a situation where the bin lid is open. Like that. We'll add a second situation where behavior is impossible, so it is not possible to throw the tea bag out if the tea bag has already been thrown out. Okay, now we're done. We can go back and have a quick look at our IU table to make sure it makes sense. And if we're happy with everything that we've done so far, we are finished, and we can go back to the home screen and generate the Spud file, which is the definition of the PalmDP instance. So we will grab that. We have a number of different options that we can add at this point, which I won't go through in detail right now. For example, you can have a calling the caregiver option. We have options to generate speech, sensor query actions, different specificities, batteries discharging, and so on. These are extensions to the basic Spud model, which can be used if necessary. We will now generate this Spud file, so this will give us the definition of the PalmDP, which we can open in our favorite text editor. It is just a simple text file, which is a description of the PalmDP. We see variables here that we have defined, our observations, a number of different sensor models, and then the rest of the definition. And at the end of this file, we will see the different actions that can be done by the system. For example, it can do nothing, or it can give a prompt for either of the two abilities of the